This is a CBS News special report. The flight of Apollo 10, brought to you by Western Electric, manufacturing and supply unit of the Bell system, as part of our continuing coverage of important news events. Reporting from the CBS News Apollo headquarters in New York, correspondent Walter Cronkite.
At this moment, one of the most dramatic moments in the flight of Apollo 10 since its launch from Cape Kennedy on a Sunday afternoon. At this hour, the crew of Apollo 10 is about 724 miles from the moon, statute miles, as the crow flies, except that no crow has been reported flying there, 247,000 miles from Earth. It's plunging toward the moon at some 5,000 miles an hour, almost 5,700 miles an hour it will be very shortly. To put it another way, Apollo 10's about as close to the moon now as New York City is to Indianapolis, a trip that a lot of us have made. It's as far from the Earth as the equivalent of 25 round trips from New York to Sydney, Australia, which few of us have attempted. A couple of hours ago, we had a last look at the crew before it headed for the dark side of the moon, the side away from Earth, outside of television and radio range. We hope to have that look at the astronauts as they reported to us a little after 1 o'clock our time 3 hours ago. Right now, they're on the way to the moon, as we say, and for lunar orbital insertion, which will come on the dark side of the moon. Let's listen to the conversation as they approach the moon, as relayed to us from Mission Control in Houston. They're coming up sporadically here as they report their last maneuvers in getting into a position which is with the back of the spacecraft facing toward the moon or their orbital path. They're pitched about 22 degrees. That is just a little bit off of the vertical. In about 5 more minutes, 4:37 this afternoon, signal will be lost with the spacecraft as they disappear behind the dark side of the moon. And then, just 9 minutes later from that, they will fire their service propulsion system engine, 20,500 pounds of thrust, for almost 6 minutes to put themselves into orbit around the moon. That is a braking maneuver. They slow down from 5,700 miles an hour, which will be their speed at that point, and in order to prevent being slung by the moon's gravitational pull back into a course toward the Earth, they will slow down to 3,700 miles an hour, which is the orbital speed around the moon. They'll go into then a high elliptical orbit around the moon with the low point at 69 miles above the moon's surface, the high point 195 miles above the moon's surface. They'll come back from that dark side of the moon and for the first time report to us how that very important burn of the service propulsion system engine went at 5:12 p.m. That's going to be quite a long wait for the men in Mission Control in Houston and all of us around the world as we wait almost breathlessly to hear how they have done in that important maneuver. They disappear at 4:37. According to the present calculations, they reappear at 5:12 as far as the communications go. The burn should come at, as we said, 4:45, or 9 minutes after the disappearance behind the moon's surface. If by any chance they find that they cannot fire the service propulsion system engine, or for any reason decide not to fire the service propulsion system engine, they will come back around the moon just a little bit earlier because they'll be making 5,700 miles an hour instead of going through that braking maneuver, of course, and then we would hear from them at 1 minute after 5. Here's a transmission from them.
10, stand by for mark. 10 minutes. Mark, 10 minutes, ignition.
They're giving them a 10-minute mark for the firing of the service propulsion system engine. We should have about 2.5 more minutes of...
Mark 2 seconds early to allow for the lag time in communication.
That's the voice of Jack Riley, in Mission Control in Houston. The voice in Mission Control, who is the capsule communicator, talking to the spacecraft, is Charles Duke.
2 minutes, LOS. Everybody here says Godspeed.
Okay, and we'll see you right on the other side in orbit.
Roger, 76, 22, 55.
LOS is loss of signal.
We'll be going.
The command module with the lunar module attached to its nose, as it has been since they linked up on Sunday afternoon, shortly after liftoff from Merritt Island, the Kennedy Space Center, goes into an orbit, or passes the moon to the left side as we look at the moon, and is grabbed by the moon's gravitational pull, pulled around to the far side. At that point, the spacecraft engines are fired to slow it down, a braking action which slows it down by 2,000 miles an hour, from 5,700 miles an hour to 3,720 miles an hour, to put it into lunar orbit. You perhaps have heard the last from the spacecraft. You've heard Houston wish them Godspeed, and Stafford say, "We'll see you on the other side," which may turn out to be the phrase from all of these moon-orbiting spacecraft, since that was the last word we heard from Frank Borman when Apollo 8 went around the moon in December. The time has come for officially the loss of signal, and presumably we have now heard the last of the spacecraft until sometime after 5 o'clock, at least 30 minutes from now. Before this flight began, David Shoemaker spoke with Command Module Pilot John Young about the reliability of Apollo 10's giant engine.
Well, I think the service propulsion system has certainly shown that it's a very reliable system. Design-wise, I don't think that it has any design problems. One thing about Apollo 10 that we didn't have in Apollo 8 is if we can't do lunar orbit insertion, you know, if for some reason the engine doesn't light and we coast out of lunar orbit, or if it lights and only burns for a little while, and then shuts off for some reason, we can still get out of lunar orbit with a descent propulsion system on the lunar module. So we're a whole spacecraft up on the Apollo 8 guys. And again, if for some reason before we start our rendezvous and stage the descent engine on the lunar module, the service propulsion system were to quit, we can redock, leave the descent engine on the limb, and use the descent engine to get us back. So we're a couple of engines ahead for a long period of time.
So the Apollo 10 is now going to the other side of the moon. It is between, the moon is between the Apollo 10 and Earth at this point, so we can't hear anything from it. Those three great tracking stations with their 85-foot dishes are hearing nothing from space at the moment. We wait now for word from Apollo 10 when it comes back from the other side of the moon. It's going to be a long 30 minutes until we get word that they have successfully fired that service propulsion system engine, about which you just heard John Young talking to David Shoemaker. CBS News color coverage of the flight of Apollo 10 will continue in a moment.
Hi, Mom. Did you remember to feed my turtle?
When you talk to someone far away, you need help. You get Western Electric. We're the people who make phones, wire that carries your voice to your Bell telephone company, switching equipment that selects a for your voice, amplifiers that keep your voice strong and clear, and equipment that puts it on a coaxial cable. In fact, all along the way, your voice speeds over a lot of things Western Electric makes.
Yes, Tommy, I fed you Turtle. Yes, dear, I'm taking very good care of him.
Western Electric is in the bell system to help make sure your voice has a smooth ride every time.
This decision to fire the service propulsion system engine there on the far side of the moon is a critical one for the astronauts aboard Apollo 10. For once they have committed themselves to moon orbit, then they, of course, have to get out of moon orbit if they're ever to come home again. They will have two possibilities of doing that in contrast to Apollo 8. The principal means and the intended means will be to fire for a second time the service propulsion system engine after they have jettisoned the lunar module. That will be after the lunar module has made its trip down to the moon's surface tomorrow afternoon and then has rejoined the command module circling overhead. However, if before they cut loose the lunar module and it makes that trip, they decide that there is trouble with the service propulsion system engine, they could use the descent stage of the lunar module itself to put them into the trans-Earth trajectory, that is to send them back toward Earth instead of forever circling the moon. But once they have gotten rid of the lunar module, then that service propulsion system engine will have to work on Saturday afternoon in order for them to get out of the lunar orbit and back on the way toward the good Earth. The flight has been absolutely perfect as far as the systems aboard the spacecraft go so far. Their health is said to be excellent, according to Dr. Charles Berry, the astronaut's physician, who says that they're in the best shape of any of the Apollo crews so far. They have had a little bit of stomach distress, gas, as a matter of fact, brought about by the hydrogen bubbles in the water supply, a piece of equipment they devised to get those hydrogen bubbles out of the water supplied as a byproduct of the fuel cells on the spacecraft did not work. That was whirling the bag around, and if you were watching television yesterday afternoon, you saw that demonstration, whirling the bag around and trying to get the bubbles to come to the surface. Well, for some reason or other, out there in the weightlessness of space, the bubbles didn't come to the surface. Instead, they all joined together in one great big bubble, and they're still ingesting a great deal of hydrogen, and it isn't any too comfortable for them. But they said they felt great when they got up this morning to the tunes of music being played from Earth here, music, the number being, on a clear day, you can see forever. And since then, they have been getting ready for these critical moments of putting their Apollo 10 into orbit around the moon. Bill Stout and Leo Krupp at North American Rockwell in Downey, California, can tell us what's going on there in the command ship right now as they pass through and into the dark side of the moon.
This outside view of our CBS News North American Rockwell mock-up, Walter, gives you some idea of how the big rocket is used for braking the spaceship. In effect, it's been flying in rear end first. Is that right, Leo? And they fire this engine to slow it down and toss it into the proper orbit?
That's right, Bill. The lunar orbit insertion burn has to be a retro maneuver to slow down the vehicle's relative velocity to the moon. Because right now our velocity is so great that if we did not slow down, we would hook around the moon into a large elliptical orbit, which would bring us out on the other side far enough to put us back into the sphere of influence of the Earth's gravitational field, and we'd come back to Earth on a free return. So if the decision is made to retro into lunar orbit, they will fire the service propulsion system for quite a long burn, about 6 minutes, which will slow the velocity down sufficiently to allow the moon to capture the vehicle into a 60 by 170 nautical mile elliptical orbit.
And then they fire again to tighten that, is that correct?
That's right. We'll stay in two lunar parking orbits while they final line the trajectory. Then there will be another short service propulsion system burn, which will further adjust the speed to put us into a 60 nautical mile circular orbit.
And then they must count on this engine again, as I think Walter mentioned a moment ago, to get them out of orbit and start them back to Earth. Isn't that correct?
Normally, we'll use the service propulsion system to come back on our trans-Earth insertion to come home. However, as Walter pointed out, on this particular flight, we do have the capability of using the lunar module descent propulsion engine to get out of lunar orbit if there emergency should arise or a malfunction in the service propulsion system.
So everything seems to be ready, Walter, for what you so aptly describe as a very critical point in this mission, leading up to man's closest look yet at the surface of the moon.
And that moment will be coming any second now as they fire the service propulsion system engine for the first time, if that is their determination, if they make no change in their plan. And this simulation shows that engine burning. It should be taking place right at this moment. It burns for 5 minutes and 54 seconds, almost 6 minutes, slows down the spacecraft by nearly 2,000 miles an hour, from 5,700 miles an hour to 3,720 miles an hour. And as Leo just pointed out, and we have before, that is the orbital speed that suspends it between the moon's gravitational pull and the momentum which would throw it on out into space again with its speed. We won't be hearing that this burn has come successfully until 12 minutes after 5, another 27 minutes from now, and that's going to be quite a long time to wait to hear that it is successful. If, however, the burn was not made at all and it held on to its 5,700 mile an hour speed, it'll be coming out from behind the moon about 10 minutes before that, about 11 minutes before that, so that 5:01 we would be hearing from it. Of course, Houston is hoping that it doesn't get that signal at 5:01, indicating that the burn did not go as planned. If the service propulsion system burned only partially, part of the burn, they could still make their corrections. They would go into an orbit around the moon, which would be in a high elliptical orbit of some distance depending upon the amount of the braking burn by the service propulsion system engine. And then if they could refire the service propulsion system engine on a future orbit, they might still go into orbit around the moon, but they probably would use it instead as a posigrade burn, that is a forward accelerating burn to get back up to their 5,700 mile an hour speed and come out from behind the moon to come back to Earth. That will be on a subsequent orbit. That is the alternate plan if the engine only functions for part of its scheduled 6 minutes. We've been talking about the command module's service propulsion system engine, this 20,500-pound thrust engine you see here now burning in the simulation. We also have talked about the lunar module's engines and the fact that the descent stage of that engine could, if needed, put the spacecraft back into its trajectory toward Earth. Nelson Benton and Scott McLeod at Grumman Aircraft in Bethpage, Long Island might be able to tell us more about those lunar module engines. Gentlemen?
Walter, we thought we'd give you a walk around of the engines. Actually, the lunar module has 18 engines altogether on it, many of them very similar to those on the command module. And right out the window here is some of the 18, the RCS, the reaction control system. Scott, we're going to be hearing terms like dips and apps and that sort of thing. Tell us about those other big engines.
Well, the RCS that you mentioned, there are 4 on each corner. They're called quads. On the descent stage, that large engine you see sticking out below, that's the descent propulsion system. That's the dips. It's about roughly 10,000 pounds of thrust. On the ascent stage, you have the ascent engine, the ascent propulsion system. That's the apps that you're referring to.
And the dips, we're told, we can use that to help bring the docked spacecraft back to the moon if necessary.
Well, yes, if there
back
should
from
be...
the moon if necessary.
If there should be a problem with the propulsion system on the service propulsion module, then you can use the descent engine from the LEM. Even though it's only approximately half the thrust, it just means you would have to fire it twice as long.
And in effect, all these engines we're talking about really don't have what you would call moving parts.
No, they don't. They have fuel and oxidizer, and when they mix together, they immediately ignite. This is the hypergolics that we were referring to before.
And hopefully the reliability is about the same as dropping a match in a gas tank.
Yes.
Walter, back to you.
That's pretty reliable. If it goes that well, but not that explosively, I hope all will go well with the flight as it has so far. Today's big events in the progress of Apollo 10 toward the moon, where in the first place, it's coming into the moon's gravitational pull. That came around 2:45 this morning when the Moon's gravitational pull took over from the Earth's gravitational pull. Up to that time, the spacecraft, just like a car going uphill, had been slowing down all the time from the time that it fired its third stage of the Saturn engine on the second orbit around the Earth Sunday afternoon. It had gotten down to a speed of just a little over 2,000 miles an hour when, while the astronauts were sleeping very soundly today, and they slept almost 11 hours, they came under the gravitational pull of the Moon itself. Since then, they have been speeding up, and they were getting up to 5,700 miles an hour as they swept behind the Moon just a few minutes ago. At 1:40 this afternoon, they went into darkness, or semi-darkness, by passing into the shadow of the Moon coming between them and the Sun at that point. That shadow lasted for about 2 hours, and they came out of the shadow again around 3:40 this afternoon. And then the big moments which are taking place right now. The service propulsion system engine burning. It's got about another minute to burn until it shuts off, if all is going well. There it is. The shutoff is shown in our simulation here. If things have gone as we show it here, the engine now is down.
A few conversations going, but not very many. Most controllers sitting at their consoles very quietly.
Jack Riley reporting from Houston that all is quiet in mission control in Houston as they wait anxiously for the word from the Moon. Word that should come in about 19 minutes from now, if all has gone well. Our simulation shows the spacecraft over the far side of the Moon, which is now being seen by the 4th, 5th, and 6th human beings ever to make this journey. The first 3 were, of course, on Apollo 8 in December, the first men ever to peer down on that far side of the Moon. Far side of the Moon has been photographed, of course, by Soviet and American lunar orbiters, but the Frank Borman crew of Apollo 8 were the first men to actually look at it, and now here are Tom Stafford, John Young, and Eugene Cernan having that look as well. We hope it's a peaceful look for them, that all is going well with them. Bruce Morton, down at the Manned Spacecraft Center in Houston, I've been talking about Apollo 8. How does this lunar operation differ from the one we saw on Apollo 8?
Well, Walter, I think the main difference is this question of safety that we've all been talking about, and that centers around the fact that, as we heard John Young say a while back, Apollo 8 didn't have a LEM, didn't have a lunar module, so that when they were going through all these maneuvers, their service propulsion system, that big 20,000 pounds of thrust rocket that we've been seeing, just absolutely had to work. If it had failed completely, they still had the one safety factor, of course, of being on a trajectory that would bring them back to Earth, but if it had started and then stopped too quickly, they could really have been stuck. And that's just not true this time. We've been talking, you have, Nelson Benton has, Bill Stout has, about all of the different combinations that can be worked here, and there really is no point here at which the failure of one engine can prejudice this flight. If the service propulsion system engine doesn't work, you can use the descent engine on the lunar module, and that will get you back in an Earth trajectory, or that will get you back in a lunar orbit. Even after the LEM separates, there are a lot of possibilities for playing one engine off against the other. The command and service module can go down and get the LEM if the LEM has trouble getting back. And there's really no point at which you can look at one of these engines and say, that's it. That, of course, won't be true next time with Apollo 11. Once you're down on the surface of the Moon, the ascent engine really does have to lift you off. But this time, there are a lot of built-in safety factors that, despite the confidence that everybody here had in 8 when it went, just weren't present that time around. Walter?
Bruce, there is that one point where there's only one engine, no redundancy, and that's in that final burn of the service propulsion system engine to get back into the trans-Earth trajectory, is there not?
There is, Walter, except that, as I understand it, if you knew in advance that you were going to have a service propulsion problem, you could come back and perhaps dock with the whole LEM and then use the descent stage to get you out of lunar orbit. It's a question of having some advance warning.
But there is that point on late Thursday, early Friday, when they send that late Thursday when they send that ascent stage on its way, orbiting around the moon on its own path, and after that, it's too late to use that engine.
Well, that's true. The other thing I think about these things is that, as Nelson said, they really are very reliable. You can have a problem, I suppose, in the feed lines. You could have a problem with the valves, although there's always a backup set of those. But once you get the fuel and the oxidizer in there, they've almost got to burn.
Yeah, right. CBS News color coverage of the flight of Apollo 10 will continue in a moment.
Forget everything you've ever known about size. Forget that an inch exists. We're taking you into a world where a speck of dust is a boulder, and a human hair a rod. It's a sub-miniature world that we're working in now at Western Electric and Bell Telephone Laboratories. A world of complex electronic circuits, some so tiny they can pass through the eye of a needle. At Western Electric, research engineers are finding new ways to make, test, and assemble these circuits. We'll be making them by the millions for new phones and equipment Bell telephone companies will use to serve you. This is the kind of thing we do at Western Electric, finding new and better ways to make the things your phone calls are made of.
Well, we've got another 17 minutes to wait, if all has gone well on that far side of the moon, before we know that it has gone well, and that the flight of Apollo 10 is going as well around the moon as it has gone around the Earth and on the way to the moon. Unless something has gone wrong and they have not fired the engines, and then we'll know that in about 5 minutes when they come around again. With me here in our CBS News Space Center is Arthur C. Clarke. And for many years, long before we dreamed that man would be going to the moon, that I dreamed that man would be going to the moon in our lifetime, he was dreaming of his great science fiction pieces, and has just done the screenplay for 2001, in which you visualize rather exotic moon travel in the future. Arthur, on the flight of Apollo 11, and now on this flight we're going to learn a great deal from these fellows, of course, about what goes on, but the Apollo 11 flight, they are really preparing the way for dress rehearsal to get the Apollo 11 successfully landed on the moon. Man's going to get out, walk around, pick up some of this space rock or moon rock. What, if you were at that first, and you may be, that first debriefing of the Apollo 11 crew, what would you ask? What's the first question you'd want to know?
Well, that's a... well, we're glad to be home, I guess. Well, you probably know that by
well,
then.
Well, then you can take your place right along with all their other television interviewers. I thought you'd have something special.
Incidentally, there's a competition just started in a British Sunday newspaper. What should be the first words that they speak when they stand on the moon? What should the very first sentence uttered by a human being on the moon be?
Crime and ninny.
I don't know.
What would you say?
Well, I only hope it isn't help.
Oh, well, that's a rather black bit of humor. I hope not, too, Arthur. What are the things that as a science fiction writer and scientist in this sense, in your own right, what is the most important thing about their finding on the moon?
Perhaps the most important thing we hope to get from the landing is confidence that we can operate and even do simple things like walking around, picking things up. It's not easy under lunar gravity, where you have only a sixth of your normal weight, where you're wearing a suit which restricts your movement. It's not easy to do apparently simple things like picking up a stone on the ground. They have to develop special tools. And really, the mission, they're only going to be outside the spacecraft for, I think, 2 hours altogether on this first mission. But the main thing is to prove it can be done and to build up confidence that there are no unexpected problems like sinking into the ground more than they expect. There are many things which you have to learn that you can do these things. And once you've learned that, then you can be much more ambitious.
Do you have any slightest thought that there is any life form on the moon?
I think it's very unlikely. There's a much greater possibility that there may be the complex organic compounds which were the precursors of life. These may exist on the moon, perhaps a few feet down beneath the surface. But it's possible that there are life forms that exist there. We think that there are life forms on Earth which might survive if they got to the moon. So if the moon's climate was ever more benign than it is now, say a few billion years ago, and if life ever got started there, or if it got splashed off from Earth onto the moon by meteorites that hit the Earth and sort of splashed bits of our oceans onto the moon, then it may still have survived a few feet underground where the temperature is not too extreme and where there may be moisture and chemicals necessary for life. It's unlikely, but it's possible.
This, of course, will be a very low form of life, not intelligent life.
Yes, probably not intelligent life. But it need not be low in the biological sense. It might be pretty sophisticated to have adapted itself to that environment.
What about the concern that some scientists have shown around the world, and indeed our own people are showing, about the astronauts bringing back a bug, a virus of some kind from the moon?
Yes, the question of back contamination. It's very unlikely, but they are taking precautions against this. It's hard to know what precautions are adequate when one deals with a very improbable event, which if it does occur may be very disastrous. You're multiplying an enormously large number by a very small number. How much money should one invest into this quarantine arrangement? And
now the intention is, in case some of our audience doesn't know, when they come back, they're going to be quarantined. The equipment is all built. They're going to be put into quarantine as soon as they get out of the spacecraft and kept in the quarantine. That same quarantine capsule is going to be transported with them right on back to Houston, and they'll be in it for 18 days.
21 days,
21 days, yeah, total. Time before
the landing is confidence that we can operate and even do simple things, walking around, picking things up. It's not easy under lunar gravity, where you have only a sixth of your normal weight, where you're wearing a suit which restricts your movement. It's not easy to do apparently simple things like picking up a stone on the ground. They have to develop special tools. And really, the mission, they're only going to be outside the spacecraft for, I think, 2 hours altogether on this first mission. But the main thing is to prove it can be done and to build up confidence that there are no unexpected problems like sinking into the ground more than they expect. There are many things which you have to learn that you can do these things. And once you've learned that, then you can be much more ambitious.
Do you have any slightest thought that there is any life form on the moon?
I think it's very unlikely. There's a much greater possibility that there may be the complex organic compounds which were the precursors of life. These may exist on the moon, perhaps a few feet down beneath the surface. But it's possible there are life forms that exist there. We think that there are life forms on Earth which might survive if they got to the moon. So if the moon's climate was ever more benign than it is now, say a few billion years ago, and if life ever got started there, or if it got splashed off from Earth onto the moon by meteorites that hit the Earth and sort of splashed bits of our oceans onto the moon, then it may still have survived a few feet underground where the temperature is not too extreme and where there may be moisture and chemicals necessary for life. It's unlikely, but it's possible.
This, of course, will be a very low form of life, not intelligent life.
Yes, probably not intelligent life. But it need not be low in the biological sense. It might be pretty sophisticated to have adapted itself to that environment.
What about the concern that some scientists have shown around the world, and indeed our own people are showing, about the astronauts bringing back a bug, a virus of some kind from the moon?
Yes, the question of back contamination. It's very unlikely, but they are taking precautions against this. It's hard to know what precautions are adequate when one deals with a very improbable event, which if it does occur may be very disastrous. You're multiplying an enormously large number by a very small number. How much money should one invest into this quarantine arrangement? And
now the intention is, in case some of our audience doesn't know, when they come back, they're going to be quarantined. The equipment is all built. They're going to be put into quarantine as soon as they get out of the spacecraft and kept in the quarantine. That same quarantine capsule is going to be transported with them right on back to Houston, and they'll be in it for 18 days.
21 days,
21 days, yeah, total. Time before they come out, which is believed to be adequate enough for any life forms that they may have picked up on the moon to become apparent.
Yes, again, it's hard to judge because that's the incubation period of most of the infectious epidemic diseases on Earth, but of course if other diseases exist, how long would they take to incubate?
Yeah. And since we haven't built up any immunity to these things, we might be wiped out by a bug from the moon that we hadn't even identified.
It's very unlikely because anything there would be so specialized it probably wouldn't enjoy us in the least.
We can even say it's the stuff of which science fiction is made.
A lot of science fiction has been made of this.
It's just past 5:01 now, Arthur. It's coming up really on 5:02. We haven't heard from the spacecraft, so we can assume that they have burned that service propulsion system engine. At least they got some burn out of it, and they have slowed up to a certain extent. They certainly haven't continued at 5,700 miles an hour. So now it's a good sign, and we've got another 10 minutes or so to wait until we get some definite word that everything has gone well and that they are really coming around into the lunar orbits that they had hoped for. Thank you very much, Arthur. We'll be talking to you a great deal more. You know you're standing right here, right by me, for some more words of interest and wisdom. CBS News color coverage of the flight of Apollo 10 will continue in a moment. We are assuming, since the spacecraft did not emerge around the moon at the moment it would if there had been no firing of its braking rockets at this time to go into lunar orbit, that it is going into lunar orbit, which would mean that we will hear from it again in just about 8 minutes from now. It should come back around the right-hand side of the moon as we look at the moon, and to be back in touch with Earth to report that it is successfully in lunar orbit. And then after about 4 hours, or 2 orbits of the moon, it will fire again to go into a 69-mile high circular orbit of the moon. Right now, its orbit would be, if all has gone well, 69 miles by 195 miles, a slightly elliptical orbit of the moon. The rest of the schedule for the evening then would involve a television transmission of the moon's surface at around 9:30 tonight, a little after 9:30. Then Eugene's sermon, for the first time on this flight, climbs down into the lunar module at 10:30 tonight, Eastern Daylight Time, for a 2-hour period, checking out the systems of the lunar module. He climbs back into the command module, and the astronauts turn in finally after a very busy day at 1:30 tomorrow morning, after 8 hours of sleep, the big day, when Stafford and Cernan take the lunar module down to within 10 miles of the moon's surface. Bruce Morton at the Manned Space Center in Houston, what's the mood down there right now in this waiting period?
Very quiet in Mission Control, Walter. This has been kind of a good time flight so far. The astronauts have had a lot of fun, and so have the people in Mission Control with the television transmissions, the sights of an upside-down John Young and so forth. But all that's changed now, of course, with the spacecraft out of communication. There's a big crowd in Mission Control, along, of course, with the regular shift, the flight controllers. Lots of astronauts have come in. Rusty Schweikert, who was, of course, on the Apollo 9 flight. The Apollo 10 backup crew, Gordon Cooper, Don Isley, and Edgar Mitchell. Most of the high-ranking NASA officials who are normally here, and a number who are stationed elsewhere. Dr. Wernher von Braun, for example, the chief architect of the Saturn rocket. Dr. Kurt Debus, head of the Kennedy Space Center, Deke Slayton, chief of the astronauts office, and just a flock of executives from North American and Grumman, the builders of the command and service module and the lunar module, respectively. The wives, as far as we can make out on this monitor and from our pipeline into Mission Control, are all staying at home watching this, I suppose, on television and waiting more anxiously than most of us to see how it comes out.
I would think so, probably. David Shoemaker has been following this flight from the very beginning, keeping tabs of every important transmission from the spacecraft and all of its maneuvers. And David, you followed all of them before this, too, in the Apollo and before that the Gemini series. What's the outstanding part of this flight so far in your mind?
Walter, I don't have particularly
original observation, but I think you could say that it's what a difference 250,000 miles makes, at least in the case of this particular crew of astronauts. They are a fairly laconic bunch here on the ground. Gene Cernan, certainly talkative enough, but they're all fairly sober individuals with quiet senses of humor, and they kind of keep tight control of themselves. And to see them in the past few days hamming it up as they have has been quite a big surprise to those who have known them. It wasn't at all what we expected.
It's the most talkative space crew we've had in the Apollo program, certainly. They're keeping the ground well advised of what they're doing, and their antics on television have been not only amusing, but informative.
They have insisted all along that they were going to see that this time we on the ground really shared in this experience of space flight. And of course, because we don't really know or understand the systems and the theories and all of the things that are working for them, it seems more dangerous to us than it does to the men that are involved in it. And so I suppose that part of this is an attempt to reassure us that space travel really isn't such a special thing, and yeah, we'll be going along in not too many more years.
One of the things that I think Tom Stafford has done for all of us and for the space program, perhaps, is this insistence on the color camera, take it along on his flight, and he really pushed for that, and it may mean, with the great success of that Westinghouse camera, that we'll get color on the moon flight, Apollo 11, which had not been scheduled up to now. Would you agree with that, David?
I would think it would be almost impossible now, wouldn't it, for NASA to resist the public pressure for a color look at the surface of the moon, even if the moon is only black and white.
What are we going to find out about the moon? What do we know about the moon up to now, David? And incidentally, I'm keeping tabs here. We're about 3 minutes now from that acquisition of signal. They should come around. I
would say that we must be in pretty good shape up there around the moon right now. That's another one of those cases where no news is good news. I suggested to a geologist the other day that perhaps we knew more about the moon in some senses than we did about the Earth, and he said that at least in one sense he would agree with that. And that is that the Earth is, of course, mostly covered by water, and therefore we do have a better idea of the topography of the surface of the moon. However, we don't have any idea at all of what's just underneath. We won't know that until we actually get down onto the surface, and once we do that, we'll have a pretty good idea, perhaps, of the origins of the Earth, because so much of our own Earth is covered by this water. So that's what I'm looking forward to. And
we're going to get some indication of that from the rock samples that they will pick up on Apollo 11. And then on future flights, I think the scientific experiments include actually some drilling, small-scale drilling, of course, to get a little bit further down than just the surface of the moon, doesn't it, David?
That's right. Perhaps we played down a little bit too much the tension here. It's amazing how in just one flight you can get used to the idea of being that far away and all that's involved. It's obviously not just another day like any other. Many of the astronauts we know have gathered at mission control. The wives tend to gather in little groups for mutual support.
And they've got about a minute and a half to wait. Any second now, we could get that acquisition of signal. Of course, they could be off a little bit on the calculations there. They count on 5:12 as their timing, but such are the radio waves that, of course, they could get small bounces and so forth. I suppose that they're watching very carefully now with just a minute to go.
You remember in Apollo 8, there was this time where we thought we heard carrier wave. We thought we heard something out there, but it wasn't yet a good enough signal to pick up the actual voices of the astronauts. There's another thing that has occurred to me.
1 minute now. Mm-hmm. Go ahead.
Another thing that occurred to me in considering their position, the spacecraft is really in the sun on the far side of the moon. You have the feeling that they're lost out there in the deep darkness, but in fact, they're actually whizzing along in the bright sunlight, probably having one of the biggest thrills of their lives.
Yeah, as a matter of fact, don't they come into a dark period just before the acquisition of signal again. The
right.
terminator, the dark side of the moon, as far as the sun is concerned, is actually about halfway, a little more than halfway around the moon, and they're in it now, or should be, and we should be hearing something in the next 20 seconds or so. These are breath-holding moments. We'll get word from them very shortly, it's hoped. that circuit up from Houston is certainly silent right now. Be nice to have Jack Riley say anything on there. We've got it turned on. It's piping through.
AOS.
AOS, he said?
They would pick up telemetry.
Yeah. So they do have a telemetry signal from the spacecraft. It has come around. According to our simulation here, they should be seeing that Earthrise on the far horizon of the moon now.
We are getting data. We don't have any voice communication yet, but at the time we got data indicates it was a very good burn.
Meaning that the data came through at precisely 5:12. Jack Riley was on there immediately thereafter saying AOS, as you heard, acquisition of signal. The data comes down in thousands of bits of information per second. It's the telemetry information that is fed from all of the systems aboard the spacecraft, as well as the biological reports, respiration, heartbeat. Besides that, there are the voice circuits and the television circuits. I don't want to talk too much here because we want to hear those first words when they come through.
Hello, Apollo 10, Houston, over.
Roger, Houston, Apollo 10, you can tell the world that we have arrived.
Roger, 10, it's good to hear from you.
I couldn't believe this thing.
That was John Young.
The guidance was absolutely fantastic, and we'll give you the burns right now.
This engine is just beautiful. Charlie, my hat's off to the guys in the trench. I love them. Yeah, kiss that man that runs MSFN. I don't know if I can do that, though, but I'll say thank you. Okay, Charlie, ready to copy your burns? Go ahead. Yeah, say thank you big. You ready to copy the post-burn report? Roger, go. Okay, the burn was on time. The burn time was 5 plus 5, 6. Our roll, pitch, and yaw angles guidance was all good. Our residuals were 0, minus 0.2, and 0. Delta VC read 7.0. That's minus 7.0. The fuel remaining is 37.7%. Oxidizer is 39.5%. The unbalance, I'd like to talk about the present unbalance is 500 increase. We're in a 169.1 by a 59.6. The chamber pressure increased smoothly throughout the burn from 98 to 103 with up at the second ball valve initiation. I take that back, Charlie. It bounced up to 98 and then smoothly from 98 on to 103 with all 4 ball valves on. The unbalance, are you still with me? Roger, go ahead. Standing by, over. Okay, I watched the unbalance go from where we left it at 200 decrease from the short burns. I didn't touch it until after everything settled down after we were into the burn for 30 minutes. At that time, the unbalance was 300 to 350 decrease. I put the oxidizer flow valve in a decrease position. I brought it up to 0. I closed it, and then it started on up. After it hit about 150 increase, I put it to increase, and it held it. Barely held it, and it creeped up from like about 250 to the present point at 500. I actually neutralized the flow valve at about 20 seconds before the burn ended, and when I put it to normal, then the increase went from about 400 to 500.
This is John Young reporting on the burn of the Service Propulsion System engine, which put the command ship and its attached to lunar module into an absolutely perfect orbit around the moon, as had been planned months, even years ago, and is in their logbook. They did exactly as they were expected to do. The engines performed exactly as they were expected to perform, and the orbit around the moon is exactly what they had anticipated. It is an important moment in the history of the Apollo program, since this is the first firing of the Service Propulsion System engine with the lunar module attached in the lunar environment, and there was no trouble with it, no anomalies, as they would say, in the space program, no vibrations, no difficulties that might have been anticipated. They did not happen, and everything is going exceedingly well up there. You heard the happy voices of the astronauts as they came around the far side of the moon, and for the first time there in almost 45 minutes were back in touch with Earth and could report that they were in lunar orbit and that all was going well. They passed their congratulations to the MSFN, the Manned Space Flight Network, for all of its work in putting them right on target. They were only 1 mile off and 11 minutes off when they arrived by the moon earlier today. They had only made one mid-course correction out of a possible 4 in their long 3-day flight to the moon. Now they spend 2 revolutions around the moon at this orbit, going out as far as 195 miles from the moon in the apollune or apogee, the high point around the moon, come back to that 69-mile low point. They fire their engines again at the end of 4 hours to circularize the orbit at 69 miles, a little over 68, between 68 and 69 miles high, and they stay in that orbit then through their stay around the moon and up to the time tomorrow when Tom Stafford and Eugene Cernan depart from the command ship in the lunar module, sweep down to within 10 miles of the moon's surface. Tonight at 9:34 approximately, they're planning to send television to us as they are in their moon orbit, and Cernan climbs down into the lunar module for a couple of hours of testing of instruments and so forth. That's 10:30 tonight. We will be on the air for the television coverage this evening, beginning at 9:30 Eastern Time. This is Walter Cronkite at the CBS News Space Center.
This has been a CBS News special report, The Flight of Apollo 10, brought to you by Western Electric, manufacturing and supply unit of the Bell System, as part of our continuing coverage of important news events. Next Apollo update on the CBS Evening News with Walter Cronkite. This is CBS.
If you like this video, please press the subscribe button to subscribe to this channel, and also give it a thumbs up. You can also be notified when I post further videos on the anniversary of this flight and on the anniversary of the flight of Apollo 11 coming up in July. You can also support this channel with a donation by using the link in the description.